The shocking truth: why electrical safety matters. Electricity is a powerful force in our modern world. It lights our homes and powers our industries. We depend on it every single day for countless tasks. This reliance, however, comes with significant responsibilities. Working with or near electricity can be very dangerous if proper precautions are not taken. Understanding these dangers is the first step toward creating a safer environment for everyone. Ignoring electrical hazards can lead to severe injuries, or even fatalities. Therefore, mastering electrical safety is not just a good idea, it is absolutely essential. It protects workers, prevents costly accidents, and ensures operational continuity. The importance of electrical safety cannot be overstated. A single mistake, a moment of carelessness, can have devastating consequences. Burns, electrocution, arc flashes, and arc blasts are all potential outcomes of electrical incidents. These events not only harm individuals but also impact families, co-workers, and businesses. The financial costs associated with electrical accidents, including medical expenses, equipment damage, and lost productivity, can be enormous. Beyond the immediate impact, there are also long-term effects to consider. These can include chronic pain, disability, and psychological trauma for those involved. Prioritizing safety helps us avoid these tragic outcomes. This short training is designed to help you understand the fundamentals of electrical safety. We will explore key regulations and standards that govern safe electrical work practices. These include important rules from the Occupational Safety and Health Administration, OSHA. We will also look at the National Fire Protection Association Standard, NFPA 70E. By learning about these guidelines, you can help prevent accidents in your workplace. The goal is to provide clear, simple information that everyone can understand and apply. Electrical safety is a shared responsibility, requiring vigilance and knowledge from all parties. Ultimately, a strong commitment to electrical safety creates a better workplace. It fosters a culture where everyone looks out for one another. It ensures that tasks are performed correctly and safely every time. This guide aims to empower you with the knowledge to make informed decisions. It will help you recognize hazards and implement effective control measures. Remember, safety is not just a set of rules, it is a mindset. By embracing this mindset, we can all contribute to a future free from preventable electrical injuries. Let us begin this journey to master electrical safety together. OSHA's 1910 Subpart S outlines electrical safety requirements for general industry. This is a crucial set of rules for many workplaces. It covers a wide range of topics, from electrical installation safety to safe work practices. The primary aim is to protect employees who might be exposed to electrical hazards during their daily work. This standard applies to factories, warehouses, office buildings, and many other general work environments. Understanding these requirements is vital for employers to ensure compliance. It is also essential for employees to know their rights and responsibilities regarding electrical safety. These rules are legally binding and enforced by OSHA. Key aspects of OSHA 1910 Subpart S include design safety standards for electrical systems. This means that electrical equipment must be chosen and installed correctly. It must be suitable for the environment and the specific use. For example, equipment used in wet locations must be designed to prevent water ingress. The standard also mandates that electrical equipment be properly maintained. Regular inspections and upkeep are necessary to ensure it remains in safe operating condition. Damaged or faulty equipment must be taken out of service immediately. This proactive approach helps prevent failures that could lead to accidents. Another critical component is the requirement for safe work practices. This includes procedures for working on or near energized parts. Practices like lockout, tagout, LOTO are fundamental. LOTO ensures that equipment is de-energized and cannot be accidentally started while someone is working on it. The standard also specifies requirements for personal protective equipment, PPE. When hazardous work cannot be avoided, workers must be provided with and use appropriate PPE. This might include insulated gloves, face shields, and flame-resistant clothing. Training is also a cornerstone of Subpart S, ensuring workers understand hazards and safe procedures. Furthermore, Subpart S addresses specific electrical installations and equipment. This includes rules for wiring methods, components, and equipment. It covers things like grounding, overcurrent protection, and guarding of live parts. For instance, all live electrical parts operating at 50 volts or more must be guarded against accidental contact. This can be achieved through approved enclosures or by locating them where they are inaccessible. employers must ensure these physical safeguards are in place and maintained. Adherence to these detailed provisions is key to preventing electrical shocks, burns, and other injuries in general industry settings. OSHA 1926. Subpart K specifically addresses these challenges. This standard provides the electrical safety requirements for construction work. This includes new construction, alterations, repairs, and demolition. The dynamic and temporary nature of construction projects means electrical systems are frequently modified. This constant change requires heightened awareness and strict adherence to safety protocols. Subpart K is designed to protect construction workers from the dangers of electricity in these demanding environments. It is a vital tool for ensuring job site safety. One of the core elements of Subpart K is ensuring the safe installation and use of temporary electrical systems. Construction sites rely heavily on temporary power for tools and lighting. These systems must be installed by qualified persons. They must also be protected from damage and regularly inspected. For instance, extension cords and temporary wiring must be appropriate for the load and the environment. They should be routed to avoid creating tripping hazards or being damaged by traffic. Proper grounding and ground fault circuit interrupters, GFCIs, are especially critical on construction sites. GFCIs are required for most 120-volt, single-phase, 15 and 20 ampere receptacle outlets. Subpart K also emphasizes the importance of maintaining a safe distance from overhead power lines. Contact with these high-voltage lines is a leading cause of electrocution in construction. The standard specifies minimum clearance distances that must be maintained. If work must be performed closer than these distances, the power lines must be de-energized and grounded, or other protective measures must be implemented. This requires careful planning and coordination with utility companies. Workers operating cranes, scaffolding, or other tall equipment must be particularly cautious. Ignoring these rules can have fatal consequences. Furthermore, just like in general industry, Subpart K mandates safe work practices and training. Workers must be trained to recognize and avoid electrical hazards specific to construction. This includes understanding lockout-tagout procedures for construction equipment and systems. It also involves the correct use of personal protective equipment, PPE, suited for construction tasks. For example, ensuring that portable electric tools are either grounded or double insulated is a basic but crucial requirement. Employers are responsible for providing this training and ensuring that safe practices are followed consistently on site. Compliance with Subpart K is essential for preventing electrical incidents on ever-changing construction projects. The National Fire Protection Association's NFPA 70E, titled Standard for Electrical Safety in the Workplace Registered Trademark, is a crucial consensus standard. While OSHA regulations tell you what you must do, NFPA 70E often tells you how to do it safely. It provides detailed guidance on protecting workers from electrical hazards such as shock, arc flash, and arc blast. This standard is widely adopted in many industries and is often referenced by OSHA as a guide to achieving compliance. Its focus is on practical safety measures, risk assessment, and establishing an electrically safe work condition. It is updated regularly to reflect the latest safety research and technologies. A primary focus of NFPA 70E is the concept of establishing an electrically safe work condition. This means de-energizing equipment before work begins whenever possible. The standard outlines specific procedures for achieving and verifying this state. This includes identifying all sources of power, interrupting the load, disconnecting the power, and applying lockout-tagout devices. Importantly, it also requires testing to confirm the absence of voltage before any work proceeds. This methodical approach significantly reduces the risk of electrical shock or arc flash incidents. Working on de-energized equipment is always the safest option. When de-energizing is not feasible due to equipment design or operational limitations, NFPA 70E provides strict requirements for energized work. This includes performing a thorough arc flash risk assessment. This assessment determines the potential severity of an arc flash and the arc flash boundary. Based on this assessment, appropriate personal protective equipment, PPE, must be selected and worn. This PPE is specifically designed to protect workers from the thermal effects of an arc flash. The standard details different categories of arc flash PPE. It also requires an energized electrical work permit for most types of energized work. Training and qualification of workers are also heavily emphasized in NFPA 70E. Only qualified persons, who have received specific training and demonstrated skills, are permitted to work on or near exposed energized parts. This training must cover hazard identification, risk assessment procedures, and emergency response. Retraining is required at regular intervals or when new technologies or job tasks are introduced. The standard also outlines responsibilities for both employers and employees in maintaining a safe electrical work environment. Adherence to NFPA 70E practices is a key component of a comprehensive electrical safety program, helping to prevent injuries and save lives. Section 5. A powerful partnership: how OSHA and NFPA 70E work hand in hand. OSHA regulations and NFPA 70E are not competing standards. Rather, they complement each other to enhance electrical safety. OSHA provides the legal framework for workplace safety in the United States. Its electrical safety standards, like 1910 Subpart S and 1926 Subpart K, establish mandatory requirements that employers must follow. These regulations set the baseline for what constitutes a safe electrical environment. Failure to comply with OSHA standards can result in citations, fines, and other legal consequences. OSHA's role is primarily enforcement and setting minimum safety levels that must be achieved by law. NFPA 70E, on the other hand, is a national consensus standard developed by industry experts. It offers detailed guidance on how to implement electrical safety programs and practices. While OSHA tells employers they must protect workers from electrical hazards, NFPA 70E provides specific methodologies and procedures. For example, OSHA requires protection from arc flash, but NFPA 70E provides the methods for conducting arc flash risk assessments and selecting appropriate PPE. Many employers adopt NFPA 70E to help them meet their obligations under OSHA's General Duty Clause, which requires employers to provide a workplace free from recognized hazards. OSHA often refers to NFPA 70E as a source of recognized industry best practices. During inspections, OSHA compliance officers may use NFPA 70E as a reference to evaluate the adequacy of an employer's electrical safety program. If an employer is following the guidelines in NFPA 70E, they are generally considered to be providing a safe workplace concerning electrical hazards. This relationship means that understanding and implementing NFPA 70E is highly beneficial for employers seeking to comply with OSHA requirements. It provides a clear roadmap for creating a robust electrical safety culture within an organization. Therefore, a comprehensive approach to electrical safety involves understanding both OSHA regulations and NFPA 70E guidelines. OSHA sets the legal obligations, while NFPA 70E provides the practical, detailed how-to information. By integrating the principles of both, companies can develop effective electrical safety programs that not only comply with the law, but also genuinely protect their workers. This partnership between regulatory requirements and industry best practices creates a stronger, more resilient shield against electrical dangers in the workplace. It helps ensure that all reasonable steps are taken to prevent accidents and injuries. Section 6. Current dangers. Identifying common electrical hazards. Recognizing common electrical hazards is the first crucial step in preventing accidents. One of the most well-known dangers is electrical shock. This occurs when a person's body becomes part of an electrical circuit, allowing current to flow through it. The severity of an electric shock depends on the amount of current, the path it takes through the body, and the duration of contact. Even low voltages can be dangerous under certain conditions. Shocks can cause muscle contractions, breathing difficulties, burns, and heart failure. It is vital to always assume circuits are energized until proven otherwise, and to use proper insulation and guarding. Arc flash and arc blast are another set of severe electrical hazards. An arc flash is a sudden release of electrical energy through the air when a high voltage gap exists, or there is a breakdown between conductors. This event produces intense heat, a bright light, and molten metal. The temperatures can reach up to 35,000 degrees Fahrenheit, causing severe burns to skin and igniting clothing. An arc blast is the corresponding pressure wave that can result from an arc flash. This blast can be strong enough to throw workers across a room, send shrapnel flying, and damage hearing. These events happen incredibly fast, leaving little time to react. Overhead and buried power lines pose significant risks, especially in construction and outdoor work. Contacting a live power line, either directly or indirectly through conductive equipment like ladders or cranes, can be instantly fatal. It is essential to maintain safe clearance distances as specified by OSHA and to treat all overhead lines as energized. Similarly, digging or excavating without knowing the location of underground power lines can lead to cable damage, explosions, and electrocution. Always call 811 or the local utility locating service before starting any digging project to have underground utilities marked. Improper grounding and damaged insulation are also frequent culprits in electrical incidents. Grounding provides a safe path for fault current to flow, preventing equipment enclosures from becoming energized. If equipment is not properly grounded, a fault can cause the metal casing to become live, creating a shock hazard for anyone who touches it. Insulation on wires and tools prevents accidental contact with live conductors. When insulation is damaged, cracked, or worn, it exposes live parts, significantly increasing the risk of shock or short circuits. Regular inspection of tools, cords, and equipment for such damage is essential for safety. Section 7. Powering up protection, practical safety tips, and solutions. Implementing practical safety tips is key to mitigating electrical risks. One of the most fundamental principles is to always de-energize electrical equipment before working on or near it. This involves following proper lockout, tagout, LOTO procedures as outlined in OSHA standards and NFPA 70E. Lockout, tagout ensures that the equipment cannot be accidentally re-energized while work is in progress. This simple yet critical step prevents countless injuries each year. Always verify the absence of voltage using a properly rated test instrument after applying LOTO and before starting work. This confirmation step is non-negotiable for safety. Using the correct personal protective equipment, PPE, is essential when energized work is unavoidable or when working near potential hazards. For shock protection, this includes insulated gloves, sleeves, and tools. For arc flash protection, specialized arc-rated clothing, face shields, and hoods are required. The level of PPE needed depends on the specific hazards identified in a risk assessment. Employers must provide appropriate PPE, and employees must be trained on its proper use, care, and maintenance. Remember, PPE is the last line of defense. Engineering and administrative controls should always be prioritized. Regular inspection and maintenance of electrical equipment and tools are vital. Before each use, visually inspect cords, plugs, and casings for any signs of damage, such as cracks, frayed wires, or missing ground pins. Damaged equipment should be immediately removed from service and repaired by a qualified person or discarded. Implementing a preventive maintenance program for electrical systems helps identify potential problems before they lead to failures or accidents. This includes periodic testing of circuit breakers, GFCIs, and other protective devices. Keeping equipment clean and dry also contributes to its safe operation. Maintaining a safe work environment is also crucial. Ensure adequate lighting in work areas, especially around electrical panels and equipment. Keep work areas clean and free of clutter to prevent trips and falls that could lead to contact with energized parts. Avoid using electrical equipment in wet or damp locations unless it is specifically designed for such use. Use ground fault circuit interrupters, GFCIs, for portable tools and equipment used outdoors or in wet areas. These simple measures significantly enhance overall electrical safety and reduce the likelihood of incidents. Everyone has a role to play in maintaining these conditions. Section 8. Lessons from the field. Real-life electrical safety scenarios. Real-life examples starkly illustrate the importance of adhering to electrical safety standards. Consider a maintenance worker who was tasked with repairing a conveyor belt motor. Believing the circuit was off, he failed to perform lockout-tagout and did not test for the absence of voltage. While he was working, another employee, unaware of the maintenance, restarted the main power supply. The motor energized, and the maintenance worker received a severe electrical shock and burns. This tragic incident could have been easily prevented by following established LOTO procedures, a key requirement in both OSHA regulations and NFPA 70E. Another common scenario involves construction workers operating near overhead power lines. In one case, a crane operator was moving materials on a job site. The boom of the crane came too close to a high-voltage power line. Electricity arced from the line to the crane, energizing the entire machine. A worker on the ground who was touching the crane at that moment was electrocuted. This highlights the critical need to maintain specified clearance distances from power lines. It also underscores the importance of site planning, hazard assessment, and communication with utility companies before starting work near such dangers. Arc flash incidents often occur during troubleshooting or maintenance of energized electrical panels. Imagine an electrician attempting to rack in a circuit breaker into an energized switchgear. Due to a mechanical fault or human error, a phase-to-ground or phase-to-phase fault occurred. This resulted in a powerful arc flash. The electrician, who was not wearing adequate arc-rated PPE, suffered severe burns to his face and hands. An arc flash risk assessment, as recommended by NFPA 70E, would have identified the potential hazard level. It would have mandated the use of specific arc-rated clothing and face protection, significantly reducing injury severity. Consider also the risks from something as simple as a damaged extension cord. An office worker noticed a frayed cord on a fan, but continued to use it. Over time, the exposed wires made contact with a metal desk leg, energizing the desk. When the worker touched the desk while simultaneously touching a grounded object, they received a painful shock. Regular inspection of electrical cords and immediate removal of damaged equipment from service are simple yet effective preventative measures. These examples underscore that electrical hazards exist in all environments, and vigilance is always required to prevent harm. Section 9. The continuous circuit committing to ongoing electrical safety. In conclusion, mastering electrical safety is not a one-time achievement, but an ongoing commitment. The standards set forth by OSHA, such as 1910 Subpart S for general industry and 1926 Subpart K for construction, provide the foundational legal requirements. These regulations are designed to protect workers from the inherent dangers of electricity. Compliance with these OSHA standards is mandatory and forms the bedrock of any effective workplace safety program. They establish clear responsibilities for employers to provide a safe working environment and for employees to follow safe work practices. This legal framework is essential for accountability. NFPA 70E, the standard for electrical safety in the workplace registered trademark, complements OSHA regulations by providing detailed practical guidance. It outlines how to perform risk assessments, establish electrically safe work conditions, and select appropriate personal protective equipment. By embracing the principles of NFPA 70E, organizations can move beyond mere compliance. They can develop robust safety programs that proactively manage electrical risks. The synergy between OSHA's requirements and NFPA 70E's best practices offers a comprehensive pathway to preventing electrical incidents, injuries, and fatalities in diverse work environments. The common electrical hazards we have discussed, shock, arc flash, arc blast, issues with power lines, and faulty equipment, are ever-present threats. However, by understanding these dangers and implementing practical solutions, we can significantly mitigate these risks. This includes diligent adherence to lockout-tagout procedures, consistent use of appropriate PPE, regular equipment inspections, and maintaining a safe work area. Real-life examples tragically demonstrate the consequences of neglecting these safety measures. They also highlight how proper training and adherence to standards can prevent such outcomes. Ultimately, creating a culture of electrical safety is paramount. This involves continuous training, open communication about hazards, and a shared responsibility among all employees. It means never becoming complacent and always prioritizing safety over expediency. The journey to electrical safety mastery requires constant vigilance, learning, and adaptation to new technologies and information. By adhering to OSHA and NFPA 70E standards, and by fostering this unwavering commitment, we can protect ourselves and our colleagues. We can ensure that everyone returns home safely at the end of each workday, which is the most important goal of all.